Welcome to Mrs. Neller's notes for her pre-calculus class. These are the notes for section 4.5, day 1, entitled Exponential and Logarithmic Equations. And today we're going to take a look mostly at logarithmic and exponential equations and different ways that we can solve them. So they're going to be more advanced equations today. Okay, now when you have an exponential equation, you have to remember that that means that the variable is going to be in the exponent. And the way we solve these to basically get that variable out of the exponent is with a logarithm. So down here at the bottom it says that we take the logarithm of each side and then bring down whatever's in that exponent. And then that'll help us get it at a linear level that we'll be able to solve algebraically. So here's that example worked out. Now they're taking the natural log of both sides, but remember that's the same as taking the log of both sides. Natural log is just log base e, okay? So they take the log of both sides, and then this x is going to drop down. So you have x, natural log of 2 equals natural log of 7. And then if you're trying to isolate the x, we've got multiplication going on here. So you're going to divide both sides by the natural log of 2. And now it's a calculator problem. This you enter into your calculator, and there's your decimal approximation. Okay, so these are the steps then that they have for solving that type of a problem. Okay, you isolate the exponent, so that means if there's any other stuff that's added or subtracted, multiplied, divided around it, you gotta get that stuff away from it first. Then you're going to take the log of both sides and bring down the exponent and then solve algebraically. So let's take a look at a couple problems where we need to do that. Okay, so for example 1 here, it says find the solution of the equation 3 to the x plus 2 equals 7. And we want to round to 4 decimal places. Okay. So my issue with this is that that x I'm trying to solve for is in my exponent. And the only way I can get that down is if I take the log of both sides. So you can take the log or the natural log of both sides. Doesn't matter, it's personal preference. I like taking the log of both sides. Mr. Kavanaugh likes taking the natural log of both sides. Doesn't matter. But now the tricky thing is this x plus 2, you have to kind of think of it as one big term here in our exponent. Okay, so when I drop that down in front, I'm going to write it in parentheses for now, but that's just to help me visually remember that they go together as one term. Okay, so that x, when I drop it down, is still being added to the 2, and then that whole thing is being multiplied by the log 3. Sometimes if students don't write it properly, they have x plus 2 log 3 equals log 7, which is also a legitimate logarithmic equation to solve, but it's not what is going on here in this situation. Okay, so then what students do is they subtract the 2 log 3 over to the other side, and that's not really what we want to do. So be careful, okay? If you have more than one term in your exponent, you want to think of it collectively as one term. So now if I was trying to solve for x, okay, I need to get rid of the stuff that's being multiplied here. So I need to divide by the log of 3. And now this part on the right-hand side is going to be just like the the change of base formula for logarithms. So we'll have x plus 2 equals, and this you just do in your calculator, log of 7 divided by log of 3, and you should get about 1.7712. And then all you have to do to finish solving for the x is subtract 2. So that'll get you x equals, and we get a negative value, but that's okay, negative 0.2288. So you can get a negative value for an answer. You can't take the logarithm of a negative number or the natural log of a negative number. But if you get a negative answer or negative answer here for this type of a problem, that's okay. We can have a negative value in there for x. It's in the exponent. That's okay. Okay, now in class, we're gonna, before we do example 4, we're gonna look over example number 2 and example number 3 in the book. So look over example number 2 and 3 in your book, because those are more examples of how to solve different types of logarithmic equations, different strategies to use. You might need some of those when you're doing your homework to prepare for your quiz and your test. Okay, so example 4 is a little bit different from example 1. It's kind of a step up. It's a little more advanced now because in the directions here, or the title, it says an exponential equation of quadratic type. So that means we're going to have something squared. And if we have something squared, it might mean that we need to factor in order to solve if it's quadratic. So if you look at this problem, it says solve the equation e to the 2x minus e to the x minus 6 equals 0. It doesn't look like a quadratic the way it's written. So we want to tweak it just a little bit to make it a quadratic. So that way we can solve it by factoring. And what we're going to change is this exponent right here, that 2x. Remember, when you have a power to a power, you multiply. Okay? So that means that this was really something raised to a power. It was e to some power raised to another power. And then they took those two exponents and they multiplied them together and they got the 2x. So what if I just rewrote it? E to the x squared. Now I have something that's squared, so I have a quadratic. And I have a power to a power. And when you have a power to a power, you multiply your exponents, and 2 times x is 2x. So I haven't really changed the problem at all. I've just rewritten it. It's still equivalent. It's just in a different form. So now it's definitely a quadratic. I have a squared term, I have my linear term, and I have my number. Okay? So now I'm going to factor. So usually we have x squared minus x minus 6. Usually we have a problem like that. So when we set up our two sets of parentheses, we have an x and an x, and then the factors of 6. Well, I'm not squaring an x here. I'm squaring an e to the x. So instead of writing x and x, I'm going to write e to the x. Because e to the x times e to the x is e to the x squared. And then I need my factors of 6. That'll get me to a negative 1. So I need a negative 3 and a positive 2. And then if this was a traditional quadratic, we'd set the little parentheses, or the stuff that's inside each of the parentheses, equal to 0. We're still going to do that here. So I'm going to have e to the x minus 3 equals 0, and then e to the x plus 2 equals 0. Now I have an exponential equation, a smaller one, that I can solve. So I'm going to add the 3 over to the other side. And then to get that x out of the exponent, I've got to take the log of both sides. But there's a certain type of log that'll get rid of the e, a natural log. Remember, the natural log is really just log base e. So if I take the natural log of both sides, it cancels out that e, and I'll get x equals whatever the natural log of 3 is, which is 1.0986 when you do that on your calculator. So that's okay. That's an acceptable answer. Then I have to do the same thing to my other little equation. Now, if you're observant, when you get to this point, you might notice that we're going to have a problem. Because I had to subtract that 2 over to the other side. So now I have e to the x equals negative 2. And if you don't notice it, and you keep going, and you take the e of both sides, I'm sorry, the natural log of both sides, so that you can get rid of the e, you can do that, but now you should really notice the problem. And the problem is you can't take the natural log of a negative number. So this part has no solution. So really, we only have one solution. We have the 1.0986. But we saw this when we did quadratics. When we're solving them, we always want to make sure we check our answers because one might work and one might not. So this sort of a situation where you have one answer and one no solution, it's not a new concept. Okay? Just make sure that when you're solving both of these, you check your work basically. Okay? You can have a negative number for an answer for x, but you can't take the natural log of a negative number. Okay, so now we're going to take a look at some more logarithmic equations and how we can solve them. And these are meant to be nice, short, and sweet, and quick, very algebraic type of equations. So they look a little intimidating, but really it's just applying those properties of logarithms that we've been learning the rest of the chapter. Okay? So when we have a logarithmic equation, this is where you're taking the log of some variable. So it says the variable occurs in the logarithm. And you can see here we have log base 2 of x plus 2. That variable is in the number that we're trying, or the quantity that we're trying to take the logarithm of. That's a problem. Okay? So how we do that then is we try and rewrite it if we can. We try and put it in exponential form. So we can do that here. We would take 2 to the 5th power and set it equal to x plus 2. And then 2 to the 5th is 32, and then you can subtract the 2. So you can get your answer that way. Another way to do that is to kind of raise both sides of the equation to the same base. And you want to pick a base that's going to cancel out the base on the logarithm. So you could take the left side of the equation, which was the log of 2, log base 2 of x plus 2, and the right side of the equation, the 5, and you could make both of them an exponent on 2. So you take 2 to the whatever the equation is on both sides of the equation. And we want to pick a 2 because our base was 2. So if you do that, then the base that you picked and the log cancel out. So now you get the x plus 2 by itself. And then you have 2 to the 5th. Well, you can do 2 to the 5th. That's 32. And then you subtract 2. So you get 30. So either strategy, either where you rewrite it with the exponential circle method, or you can take the the base of both sides, I guess is a good way to summarize that. You're raising both sides to a particular base. Now this method is especially helpful when you have natural logs. And that's what we're going to see in our examples in a moment. Okay, so again, we want to isolate the logarithm, and then we either want to write it in exponential form or raise the base to each side of the equation. There we go, raise the base. And then you finish solving algebraically. Okay, so I'm going to start here. This is our last example. I'm going to start it with part B because that looks very similar to the problem that we just walked through. We have log base 2 of 25 minus x equals 3. So this one, since I have a base on my logarithm, it's set equal to something. I have a term here that I'm taking the log of. I would rewrite this with our exponential method. So I would do 2 to the 3rd equals 25 minus x. And 2 to the 3rd is 8. And then you can subtract the 25 over. So you get negative 17 equals negative x. Because if we subtract the 25, it's going to cancel out. And so then x is 17. Now for part A, you could approach that either way. You could do the little circle method, write it in exponential form, or you could raise the base on both sides. So remember, the natural log is really log base e. Okay, so you could do e to the 8 equals x, and then do that in your calculator and you'll get your answer. Okay, so that's one way to approach this with the exponential way. The other way is to take or to raise the base of both sides. Now the base on a natural log is e. So you want to take e to the natural log of x equals e to the 8th. So you make whatever's going to cancel out that log, whatever that base is, you make that the base, and then you make the original part of the problem, the exponent. Okay? So what that does then is it cancels out the natural log and the e. So you have x equals e to the 8th. And that's the exact same thing that we had. Okay, so now it's a calculator problem. You have to do e to the 8th, and you get 2,980.9580. So I think when you're dealing with natural logs and you're trying to get that out of there, instead of rewriting it as log base e and then doing the circle method, just take e of both sides. Do the raise the base on both sides. Now, if you want more examples and you want more practice with this, then look over example number 7 and 8 in your book. And in class, we will definitely look those over and talk through them. So if you have any questions when you're practicing these homework problems, come on in and see me before school. Remember, all the solutions are worked out in the binder in the classroom, so you can check that too. And pay close attention here. For 37 to 57, you're doing every fourth problem.